What is printing people? Welcome back to Custom 3D. I'm your host, Max Willett. Today, our video is going to be about the differences between the industrial and the hobbyist market of 3D printing. I'm going to start off the video by talking about what companies are the big players in the 3D printing industry. So we're going to start on the industrial side, and I'm only going to name a couple companies, and those companies are Stratasys and 3D Systems. Now, on the hobbyist side, it's a little different. You have lots and lots of different companies that make hobbyist level 3D printers, but just for the sake of time and examples, I'm going to name two, or I'm going to name probably like 4 or 5. So basically, we have Creality, Ultimaker, MakerBot, and Anycubic, just for an example's sake. There are obviously lots of other different companies that make 3D printers that you can buy on Amazon, but just for the purpose of examples, that's what we're going to use. So, which came first, industrial or hobbyist? So in my last video, one of my other videos, I went over a brief history of 3D printing, and I brushed over Stratasys, and I didn't name 3D Systems, even though they were technically the first 3D printing company to really come to fruition through Chuck Hull with the first SLA 3D printer. So that's what they do, is 3D Systems is the biggest player in SLA, or stereolithography technology. Stratasys invented FDM 3D printing, the one that hobbyist 3D printing really took a hold of. And then on the hobbyist side, again, you have a lot of FDM machines, and while there are SLA machines, I think, I'm just going to, focus on the FDM machines for now. So let's talk about some of the machines that the industrial market offers. So I was lucky enough to work in this market for almost a year, and I worked with a lot of industrial machines. So basically, the line of 3D printers that are offered by Stratasys, and that's the company that I worked for. I worked for a company that did what Custom 3D does, which is prototyping through Stratasys, and they had this whole global market database that was really interesting and cool. But basically, they have the line of 3D printers starts basically at 18 grand is the least expensive printer you can get, and that's like the F120 series. It's all FDM. Most of them in the F120 series can print in ABS, ASA, and maybe TPU, and it's all proprietary. What Stratasys sells, you have to use. You can't mix and match filament with printers. They all come, some of them come in boxes, some of them come in canisters, and you have to use that filament, and it has NFC chips in it, so that you can't basically cheat and use different filaments. And then the range goes up from there. You have the F370, which is a bump up. That's part of the F120 series, but that's like the next step. So you have the F120, then you have the F370, and then after that you have the 380, which is where you start to get really industrial. The F120 series is really office-oriented printers, for engineering firms. And then when you get to the 380 and up, that's when you talk about manufacturing and short-run production is what those printers are really meant for. And then from the 380, you have the 450s, and these machines they're just basically a 380 with a larger build volume and more material slots. So you can put in 2 model material and 2 support material slots, so that you don't have to change the filament out as much. And then after that, you really get bumped up to the F900, which is the largest FDM 3D printer available by Stratasys, I believe. It's the dimensions of the build volume are 3 feet by 2 feet by 3 feet. Massive. And I think they just came out with like an F770, which is basically the same thing, except you can only print in ABS and ASA, so there's some cost savings there. And it's a little bit of a larger I believe, y-axis in terms of build volume. Other than that, I think it's the same. But yeah, so what's special? What differentiates these printers from, say, a CR10 offered by Creality? So these industrial machines, every single one of them offered by Stratasys, are fully enclosed in heated build chambers. You hear a lot about printing with ABS on an open printer like a CR10, open meaning that there's no surrounding of it. It's extremely difficult to print because you have layer separations, it peels off the build plate, and it's just incredibly difficult to print with this. And basically with enclosed build chambers, they're ovens. Think of literally the oven at your house, but with a 3D printer in it. And it's able to keep it warm, so there is no layer separation or peeling off the build plates. So that's really the only advantage these printers have over hobbyist printers, and that advantage is big enough for them to ask tens of thousands of dollars for their machines, which for some people is okay. You know, you're looking at people that are in different markets than the person looking for a CR10. So basically, the material range in these machines are all hard plastics. The only machines you can print in TPU are the F120 series and the F370. The 380, like I mentioned, and the 450 and the 900, you cannot print in TPU. And basically, you print the base materials: ABS, there's ASA, there's PC, there's nylon, there's nylon carbon fiber, there's Ultim, and then there's ABS. There's a different type of ABS. Oh man, what was it called? Well, it's I can't remember, but there's specific type of ABS for different applications. There's polycarbonate blend, and it's all really industrial materials that are all very strong. And basically, in these machines, it has dual print nozzles, so it's one head with dual nozzles instead of an IDEX system with two independent print heads and nozzles. So basically you have a support material which is dissolvable in a chemical blend, which is very convenient because if you have a part with a lot of support material, you just pop it in this chemical mixture, usually in a sonic wave wash or something like that. It dissolves the material off in a few hours and you have a part that looks awesome. I did notice that on a lot of black parts though, the support material would seep into the part, and sometimes you get like whitewashing on the part, and with a little bit of scrubbing and using a canned air, you can get it off. But yeah, so that's basically what industrial machines offer on the FDM side. Now Stratasys also offers a polyjet printer, but that's a topic that we can move on to later. So on the hobbyist side, obviously it's a lot more limited in terms of the materials that you can print reliably with. Yes, there are printers that you can figure out and try to get ABS on and maybe get them working, but it's a real pain in the butt. A lot of these printers on the industrial side are the definition of plug and play most of the time. They're very reliable machines for what they do, but obviously they're not perfect. They still have issues, and when you do have an issue, you can't fix it yourself. You have to get a tech from Stratasys to come fix them, which is fine because when you spend that much money on something, you want a professional to fix them. I don't want to fix them myself. It's the difference between when you're spending $300 and $300,000 on a machine. So let's talk details in terms of what you can print. So the difference, and you may find this surprising, but most of the time when you print on a hobbyist printer, you can get higher detail out of your prints. Now, why? So when you print on these industrial machines, most of the time you're printing industrial parts. It's a lot of fixture. It's a lot of fixtures and right angles and things like that, and you don't really require a lot of detail. And honestly, that's probably 60 to 70% of the jobs that those companies do is industrial short run manufacturing parts. And you don't need a lot of detail. So these printers don't do a lot of detail. You know, you can't print a lithophane on a FDM Stratasys printer. Wouldn't knock that off of the printer because that's not what its intended use is. Its intended use is to print industrial parts in short run manufacturing.
So guys, thanks for watching today's video. Make sure to check out all the links in the description below. I hope you learned something today. And make sure to subscribe, like, comment, and share the video if you can. So thanks guys, and I'll catch you in the next one.